Hi guys. So here we are going over the notes, Unit 8, Section 3. So we're still talking about rational functions, but this time we were given the two functions, numerator, denominator, and then we're going to calculate to see what the table would look like for the final rational function. So what I did here, I did 0 divided by 6 is 0, 6 divided by 2 is 3. This one is special because I have 0 over 0. That is undefined, but it's a different kind of special when I compare it to negative 12 over 0, and that's going to be the vertical asymptote versus the whole. So when I have the 0 over 0, that means both factors are in the numerator and the denominator. But then when I only have the 0 in the denominator, that means that's the vertical asymptote. So all the others, they're just simple division. Here we just simplified and all that. So now, for those of you that like to color code, when y is 0, I know that's going to be the x-intercept. So I have 2. In this case, I have negative 5, 0, and 2, 0. Those are my two x-intercepts. I know the whole is going to be here somewhere. I still don't know what the y value is yet, but I'll get there. I also know the vertical asymptote right there is at x equals negative 2. What else do we have? Oh, the y-intercept, 0, negative 5, because the y-intercept, the x is 0. And from here, we're going to be able to write the factors. I like to start out with the whole. So here, we know they share the same factor for numerator and the denominator. So if x equals negative 3, I know the factor will be x plus 3. And since they're the same for numerator and denominator, x plus 3, right there, whole. Okay, and then next, I did the x-intercepts, x plus 5, x minus 2. And I got those from the table here or from over here. And then finally, I wrote the vertical asymptote right there from right there. So when x is negative 2, I know the factor is x plus 2. So here is my rational function right there in factored form. Now, the next thing we did was to find the horizontal or the slant asymptote by comparing the degrees of the numerator with the denominator. So the degree of the numerator is 3 because x times x times x is x cubed. So 3 for the numerator and squared or degree is 2 for the denominator because x times x is x squared. So when the degree of the numerator is greater, I don't have a horizontal asymptote. That means I will have a slant or oblique asymptote. And I will be able to find the equation of the slant asymptote by dividing. After I simplify the whole, I'm dividing this by this. But I need to write this in standard form to be able to do the division, the synthetic division. So I did that right there in the bottom. So x plus 5 times x minus 2, when I multiply, FOIL, or box, either way, I get that. And then I'm going to use the coefficients to perform the synthetic division. Bring that down. That's 1. Multiply. That's negative 2. Add. That's 1. Multiply. That's negative 2. Add. That's negative 12. And in this case, the remainder for this doesn't mean much because what I really need is the linear function that I get from here. So in this case will be y equals 1x plus 1. And that's going to be the equation for my slant asymptote right there. Okay, at this point I have enough information, except for the whole, to draw the vertical asymptote the slant asymptote and plot a couple points here. And that's what I'm going to do. So the vertical asymptote is right there at -2. The slant asymptote at y equals x plus 1. This is the slant asymptote. I'm going to plot a couple points. -5, 0. -4, 3. I don't know where the y is for the whole. I need to calculate that. I can do that next. -1, -12 is going to be over here off the graph. So I'm not going to graph that one. 0, -5. 1, -2. 2, 0. And 4, 3. And I know the behavior of this graph will approach both asymptotes right there. But before I graph that, I want to find the whole. I have y equals x plus 5, x minus 2 over x plus 2. And then I'm going to substitute -3 that I have it identified right there to find the y value. So -3 for x, that's a plus. And here we have 2. Here we have -5. That's -10 over -1. You simplify down to 10. So this is your y value for the whole. So right there. And I'm going to plot that. So -3, 10. There's the whole. And I know the graph will approach the asymptotes right there. And it will approach the asymptote right there. And since we're here, might as well just finish labeling the main parts. I already labeled the vertical asymptote, the slant asymptote. This is the x-intercept. So is this. And the y-intercept right there. This side is a little crooked, but you know, it's fine. Okay, what else do we need? We already have the rational function here. Let's write this in standard form. Why not? Haha. So I have this. This is the x plus 5, x minus 2. I have the trinomial here. I just need to multiply that by x plus 3, and that will be my numerator. So x plus 3 times x squared plus 3x minus 10. You can't see. So I'm going to multiply. Multiply again. That's a 9. We're going to combine. That's a squared. Okay. All this to come up with the rational function in standard form. That's the numerator. I'm going to do the same thing to find the denominator. So x plus 3, x plus 2, multiply, I get x squared plus 5x plus 6. So that's my rational function in standard form. And we need the domain range. Sounded funny. So the domain is going to be all x values started right there at negative infinity. And it approaches the whole right there at negative 3. So there's a gap on the graph right there at negative 3. And then there's another gap on the graph right there where the vertical asymptote is. And then it keeps going from negative 2 all the way to positive infinity. And that's what we're going to write for the domain. So everything started at negative infinity up to where the whole is at negative 3. And then from negative 3 to negative 2 to where the vertical asymptote is. And then from negative 2 to positive infinity. Now the range, when I look at the graph, starts right there at negative infinity. And it goes, I don't have a horizontal asymptote, so I don't have to worry about that. But I do have a hole here, though, right at 10. However, on this side, I don't have a hole on this side. And that side keeps on going. So it will eventually give you a y value right here. So there's no gap on the graph right there for the y values or the range. So the range in this case will be all real numbers or everywhere from negative infinity to positive infinity. And I'll make another video for the next page.